Hello to all physics enthusiasts and fans of physical experiments. This is Andrei Shetnikov, and indeed today I won't be conducting experiments, but doing some calculations. Because one of our viewers under the video dedicated to the Darius rotor asks the question, why not install such rotors or other devices directly in the river and use them to convert energy into electricity? And now I will calculate how much energy could be extracted if I installed such a power plant. Well, where in our native Ob River, I will use its data. So the water flow speed in the Ob River is around 1 meter per second, and the river is relatively calm. Now we need to take the energy density, RV2 divided by 2. So the density of water is 1,000 kilo per cubic meter, multiplied by V2 divided by 2, and we get 500 joules per cubic meter. Now we need to know how many such cubic meters flow per second of discharge. The reference book states the average yearly water flow is 1,600 cubic meters per second. Thus, we find the transferable power. We need to multiply the energy density by the volumetric flow rate, and we will have joules per second, that is watts, which I will convert to kilowatts, and I get 800 kilowatts. Well, generally speaking, very, very little. And at this point, those who watched our video about the Betz limit for wind turbines, we must say by analogy that this value was also overestimated, because if we take away all the kinetic energy from the water flow, it means it will stop. And where will the next portions of water flow if the previous ones are standing still and not allowing them to pass? So, this value was also greatly overestimated. But now I must say, we also have a hydroelectric power station in Novosibirsk, although small. Nevertheless, the Ob-Sea is considered the pearl of Akademgorodok. And now we will also calculate the power of the hydroelectric power station in order to efficiently and accurately. And here the main parameter will be the calculated head, which at our power plant is 17 meters. This is the height difference between the upper and lower pools. Well, accordingly, the density of stored energy, it is now Arg. I multiply by 1,000, take another 10 and 17, and get 170,000 joules per cubic meter. And in the previous calculation, it was 500, so now it's 340 times more. Well, it's clear why, isn't it? Because the water falling from this height of 17 meters gains much more speed than that 1 meter per second. Well, now I have to take the same average annual flow rate of 1,600 Moasti cubic meters per second and achieve a power output of 270 megawatts. Well, obviously it's 340 times more than a flatland non-pressure generator, or more precisely, such a system of generators that has blocked the entire river. And now it's time for our traditional final question. And this time it will be as follows. The Ob Reservoir begins in the city of Kamenna-Obi, which is 240 kilometers from Novosibirsk. And if, for simplicity of calculation, we assume that the surface of the water in the reservoir is horizontal, which is not entirely accurate, then it turns out that the water level in Kamenna-Obi is 17 meters higher than the water level in Novosibirsk, since Novosibirsk is located below the reservoir. Now let's go back to the times when the reservoir did not yet exist, and the water flowed from Kamenna-Obi to Novosibirsk. Over these 240 kilometers, its level dropped by 17 meters. In our calculation, we say that each cubic meter of water in Kamenna-Obi relative to Novosibirsk had potential energy, which we can consider as 340 units, as it is convenient for us. And from this potential energy, only 1 unit transitioned into the kinetic energy of the same cubic meter in Novosibirsk. The question is, where did the remaining 339 units of energy go? What are your thoughts on this? Write in the comments to this video on YouTube.